Hi, I'm Jay McClellan, and today I want to show you my new setup for macro and micro photography and videography. I've also built a 5-axis CNC motion control system for shooting micro video, and I'm not going to cover that in detail today. I'm going to do a separate video on that, so I'll just touch on it briefly. I built the setup in a very robust fashion in an effort to control vibration. Vibration is a problem for regular macro photography because it can cause blurry images, and to some degree you can compensate for that with flash illumination, but I'm shooting video where flash is not really practical. I'm using continuous illumination, and vibration really can spoil the end result, so I built this thing really sturdy in an effort to try to minimize that. For the base, I used this Thor Labs optical breadboard. It's 18 inches square and about 2 inches thick, and it has integral vibration dampening characteristics that help out. These are kind of pricey to buy new, but I found this one on eBay and got a reasonable deal on it, so it was fairly affordable. The breadboard sits on 4 sorbothane rubber vibration isolators, and each pad is rated to support between 13 and 29 pounds. My entire setup weighs about 80 pounds by the time I have all the stuff on it, so I have on average about 20 pounds per corner, which is right about in the middle of its vibration isolation range. The main support columns are made from 1545 aluminum extrusion, which is quite beefy, and it's bolted down to the breadboard using these brackets from 80/20. I've got 4 of these brackets on each of the columns. In the video description, I'll put a link to a page on my website where I've got a complete parts list of all of these items in case you want to build your own. The crosspiece that supports the camera and optics is another piece of the 1545 aluminum extrusion. The microscope optics and camera are mounted on an Arca Swiss base plate, and they go into this Arca Swiss clamp so I can remove them easily to change out for different optics, etc. I have a linear motion stage mounted onto the cross rail, and that's the focus axis for the camera so that I can use it for focus stacking. I designed these brackets on the sides to allow me to position the camera anywhere from horizontal to vertical or any angle in between. If I loosen the knobs on the side, which I can do quickly and without tools, then I have a wide range of adjustment of camera angle. And I can do this with the camera attached. I just left it off so you can see it more clearly. But you can see I can adjust it anywhere from horizontal to over 45 degrees down and over 45 degrees looking up if I want to. To get angles closer to vertical, all I have to do is bring it up, slide it over, and then fit the bolts into one of the next slots over. To make the brackets, I just cut them from lengths of 2.5 by 1/4 inch aluminum angle. I ripped down one side so that I would have more room in between them to fit the camera assembly. And then I milled the slots on my milling machine. Now, if you didn't have a milling machine, you could use a drill press and a hacksaw, and you could do it, but it sure is a lot easier with a little benchtop mill. So that's the mechanical design, and it's very simple. Really what makes it work are the sliding brackets on the side that allow me to very quickly reposition the camera at different angles. And I'm going to put a link to a mechanical drawing of these brackets out on my website with a link in the video description in case you want to make your own, because it did take a while to figure out the angles of the slots to get it so that I'd have a full range of adjustment. Here's an example of what I can see with this, and this is the compound eye of a common fly, and I'm looking at it through a 10x microscope objective, so my depth of focus is very narrow. You can see as I move the focus axis manually that the focus point shifts in and out. But what's noteworthy as far as the mechanical design is that I'm hanging on to the back of the camera, or the back of the slide that runs the camera, and you can see very little motion from my hand. It's very stable and very solid, and that's due to these massive support columns. Here's an example of the smoothness of motion I can get with the motion control system. Here I'm going to command the x-axis to move 100 microns to the left. And similarly, I can move the y and the z. Y and z look kind of similar because the camera is at an angle in between them. Here I'm moving the rotation axis and rotating slowly. And what we want to see here is that the image, at least the portion that's in focus, remains very crisp. We're not seeing vibration going on. If it were vibrating, I'm just going to beat on the base plate a little bit, we'd be seeing this. We don't want to see that. We want to see a nice stable image. So mechanically, I'm pretty happy with the design, that it's keeping the vibration well controlled even when the subject is being moved with the motion control system. Well, I hope you found this interesting and possibly useful. And in my next video, I'm going to go over the motion control system that I built using the Raspberry Pi and the Octopus, Big Tree Tech Octopus control board and Clipper software. So stay tuned for that. Thanks for watching.